Howdy everybody, hopefully your day is going well. Welcome back to the barn one more time. So we've been working on different types of probability and we've used the multiplication rule, the addition rule, we looked at the conditional probability with the given. So there are just a couple more little types of probability. There are about 3 more types of probability we're going to look at. 2 of them are small, 1 of them is big. Okay, so not little ones. But today what we're going to talk about is some counting techniques that will help us calculate probabilities. Okay, so a lot of times when people hear the word counting, they honestly just think 1, 2, 3, 4, 5. And that's not what we're talking about here. And honestly, this is my area of expertise. So when I went to college and you get a degree in math, you don't just get a degree in math, but you specialize in a particular subject. So my specialization is called combinatorics. And combinatorics is just a fancy way to say counting. But it doesn't mean 1, 2, 3, 4, 5. I can do that. I didn't have to go to college to do that. What it means is how many ways can you get a pair out of the deck of cards? When you roll a pair of dice, how many ways can you get a 5? Okay, so it's calculating patterns and how many ways we can get certain things. So like how many social security numbers are there in our current social security system? Okay, things like that, license plates, telephone numbers, credit card numbers, not just counting the numbers, but actually counting how many. Okay, so that's what we're going to look at here. So we're going to talk about a couple counting techniques that we use. And the main one is one we've actually kind of seen before. We probably just didn't put a name on it before, but it's called the fundamental counting principle. And it says, if task A can be completed in M ways, and task B can be completed in N ways, then completing task A and B can be done in M times N ways. Okay, so this is honestly just a kind of a repetition of the multiplication rule. Okay, so the idea is if you want to do something and then you want to do something else, well, as you do things in order, then we can use multiplication, just like we did with the multiplication rule for probability. But this says, like, if you can, when you flip a coin, there are 2 ways that you can get an answer, right? It's heads or tails. And then if you flip a coin again, there are 2 ways to get an answer there. So if you want to do this twice in a row, there would be 4 ways in total. So it's talking about doing one task and then another. Now, the example that we're gonna look at is dice. So up until this point, we have only thrown a die. Okay, we've only thrown a die because I wanted you to start off with something you knew. 6 sides on the die, good to go. But what if we look at a pair of dice? So not just 1 die, but 2 now. And remember when we talked way back about the sample space? Okay. Well, if it was just a single die, our sample space was just 1, 2, 3, 4, 5, 6, right? But now, if our sample space, or if we're looking at a pair of dice, our sample space is the actual pairs. So we could say that one of them could be getting a 1 and a 1. One of them could be getting a 1 and a 2, a 1 and a 3. Okay, so you see the pattern that's going on here? Now, I don't want to write them all down. What a pain in the butt, and it might be easy to miss one. So I just want to know how many outcomes in total. Okay, so instead of doing that, I just want to know how many outcomes there are. And most people, because the die has 6 sides, they think, well, if you pick up a pair of dice, then that's 12 sides, 12 outcomes. But let's think about this a little bit. Using the fundamental counting principle, and kind of, I use little slots like this just as a visual. So let's say that this is the first die and this is the second die. Okay. So there are 6 sides on this die. So there are 6 different options for that first one. And then there are, again, 6 different options from this one. Now, from the fundamental counting principle, or if you just heard I said and then, it means we're going to multiply these, not add them. So there are 36 different arrangements of the dice when you throw a pair of dice. So now what if I asked you, find the probability, so we want to find the probability of getting a sum of, let's go with 10 on the dice. Okay, so we want to get a sum of 10. So what we need to do is we need to think about all the different arrangements of the dice that could give us a sum of 10. So the first one would be if we got a 5 and a 5. Does everybody agree? If we got 2 5s, we'd get a 10. Another example would be a 6 and a 4, but we also have to take into account the 4 and the 6 because these are 2 different die. So 6 and 4 and 4 and 6 are 2 different options. Okay, now let's see. How about 7 and 3? Could we use 7 and 3? Okay. And the idea there is no, we can't use 7 and 3 because is 7 on the die? It's not. So there's actually only 3 ways that we can get a sum of 10. A 5 and a 5, a 6 and a 4, or a 4 and a 6. So that means there's 3, but then we need to divide it by the total, and we now know that there are 36 different outcomes. Okay. And we get 3 divided by 36 is 0.0833. So if you're playing Monopoly or whatever and you want to get a sum of 10, there's an 8.33% chance that that's going to happen. Right? Okay, so let's look at another one here. We'll stick with dice for a while. Okay, so this time we're going to roll 4 dice. Now, let me take a 5-second break to go yell at the dog. Let go! Let go! In! Let go! All right, well, he took off, but I don't hear him bark anymore, so that's a good thing. Okay, sorry about that. Okay, so we're gonna roll 4 dice. Okay, roll 4 dice. So the first thing I wanna know is how many outcomes are there? Okay, so even before I ask a probability question, we should be able to figure out how many outcomes there are if we roll 4 dice. Now again, I'm not actually gonna list these, I'm just gonna use this little counting principle and use these kind of little spaces. So if each one of these represents a die, there are 6 options on each die, yes? So the fundamental counting principle says to multiply across. So that would be 6 to the 4th power. Let's see what we get there. That is 1,296. So if you're rolling 4 dice, there are a lot of different outcomes. Definitely not something that we want to like list out or anything. So 1,296. Now, let's see, what probability question will I ask you? Let's say, find the probability of getting 4 of a kind. Okay, so you're gonna roll all 4 dice and you want 4 of a kind to pop up. So 4 of a kind means that they're all gonna be either 1s, or they're all going to be 2s, or they're all going to be 3s. So that's what 4 of a kind means. So if we're looking at calculating a probability, how many 4 of a kinds are there? Right? There would be 6. 1s, 2s, 3s, 4s, 5s, or 6s. So there are 6 4 of a kinds out of this total huge number. So when we calculate this probability, 6 divided by 12, 96, we get 0.00463. So the chances are small, aren't they? Okay, there's less than a 1% chance that you're going to get a 4 of a kind, 4 of a kind when you roll 4 dice. And yet it's amazing, it still happens, right? Oh my gosh, guys, today is Animal Day apparently. Geese, way, turkeys. Okay, I closed the barn so it won't drown them out entirely, but hopefully enough so that you can hear. Did you ever think that you would be doing math class with dogs, geese, turkeys? There is a cockatoo over here in the corner. Want to come say hi, Handsome? Here's Handsome. So Handsome sits and watches me do these lectures for you every day. Yep, he does. He's the smartest mathematical bird in the world, aren't you? He says, yes, I am. Except for Archimedes, the highly intelligent owl from Stored in the Stone. If you haven't seen that, watch that. Okay, so Handsome's gonna go back over here. Okay, so, sorry, back at this. Okay, so instead of actually having to roll the 4 dice or even write out the sample spaces, by using this fundamental counting principle, we're able to find these probabilities. Okay, so let's look at another one here. I guess we can get rid of that. Okay, so my question is, or the question looks like this. 4 people are headed to the bathroom. What is the probability you will be first in line? Okay. So 4 people are headed to the bathroom, and we're gonna make the assumption that, you know, all 4 people are the same distance away. So when it comes to getting in line, you all have an equal chance of getting in line 1, 2, 3, or 4, okay? So independent, okay, we're making that assumption there. So I want to find what is the probability that you will be first in line, okay? You really have to go, so you wanna be first in line there. All right, so what we're gonna do is we're gonna think about the counting part of it first, then we'll do the probability. So if 4 people are headed to the bathroom, we'll consider these to be the 4 people. Okay, here's the outhouse over here. What do they normally put on outhouses? Moons. There's the outhouse. Okay, so as all these 4 people are rushing to the bathroom, okay, because they all have an equal chance of getting there, how many different options do we have for this first slot in line? There are 4 different people, so there are 4 different chances for that first in line. But now that there's someone standing there, when the people that are fighting for the second in line are fighting for it, how many options are there for that one? There are only 3 because someone is standing there, right? Now someone is standing here too. So now there are only 2 people left to fight for this position. And once someone's gotten that position, nobody's fighting for this last one. There's just one option. The last person comes and stands at the end of line. Okay, so that's what we've looked at here, is using that fundamental counting principle, thought, okay, if we were gonna put people in line, how many ways could that happen? So we need to multiply, okay, and that will give us 24 if we multiply out. Now, what I want you to calculate is you being the first person in line. Okay, so we're gonna do the same thing, but we're gonna make this guy be you. Which means as the 4 people are rushing, but you wanna be first in line, it means that there's only one option for that first slot. It's you. You're gonna get there no matter what. Okay, so now you are standing here, but things are still happening over here. So now there's still how many people fighting for this second slot in line? 3. Okay, now how many people are still fighting for this one? 2. And then again, nobody's fighting for that one, so just 1. Okay, so if you want to be the first in line, it takes that 4 out and it puts you as the only option for that first. So when we multiply here, we get 6, right? 1 times 3 times 2 times 1. So now if we want to find the probability that you are first in line, well, we know that there are 6 ways that it can happen. There are 6 ways that you can be the first person and then you really don't care what's going on behind you. So there's 6 ways for that to happen. Out of the total 24, and what is that? That is 25%, so 0.25. All right, so this is the fundamental counting principle, okay? And yeah, you might see a question like that, but a lot of your questions are gonna be more along the lines of like dice and stuff. So then there's one other counting technique that we need in this class. There are lots of counting techniques, okay? There's lots, like I said, this is what I specialize in. So I went to school for years to learn all this stuff. We're just doing the basics. But what we need to look at are combinations. All right, so combinations, when we choose elements from a set where order doesn't matter, this is called a combination. So if we're going to choose an element from a set where order is not an issue, so it doesn't matter who we choose first or who we choose second, which is different from over here, yes? Okay, so where order doesn't matter, then what we're doing is we're finding a combination. So a good example of this is what we call the committee problem. And in the committee problem, it says there is a club of 4 people. They need a bake sale committee of 2 people. Okay, so 4 people in their little club here, and they need a bake sale committee of 2 people. So they need 2 people to put on the bake sale. Okay, now, if you're gonna put on the bake sale and you're chosen as a committee, does it matter whether you're chosen first or second? I mean, like, unless you're, you know, very vain or egotistical, you don't really care if your name is first or second, okay? So you're gonna say, hey, you 2, go over and do a bake sale, all right? So the order doesn't matter here, but we're gonna select or choose 2 people from the entire 4 people. So let's just name these people A, B, C, and D just to make life easy. So the different committees that we could have is, it could be A and B, couldn't it? Or it could be A and C. Or it could be A and D. But maybe it's B and C, or maybe it's B and D. Or maybe it's C and D. Okay? So now, remember though, that like A and D and D and A, in this case, these are the same, because they're still the same committee. So this is what we mean by order not mattering. Okay, so this we don't need, because the order doesn't matter. It's just you two standing over there. Okay? So these are the different options there are. So if there are 4 people and they need a bake sale committee of 2, there are 6 committees possible. Okay. So there are 6 different ways that this could happen. Now, I know that we didn't miss any because I actually know the math behind this. So I knew before we started that the answer should be 6, that there should be 6 different arrangements. So the question is, how did I know that? And that's with a combination. So I'm going to define this again a little bit more mathy, okay? So this says a combination is any subset of n elements chosen from R elements where order doesn't matter. How many combinations is found written either NCR, okay, like that, where the C is a capital C and the N and the R are subscripts. Okay, so NCR, which equals, you know what, actually we don't need the formula, so let's maybe put it up there. Okay, so but we could write it a different way. So another notation for this is N over R, notice no fraction, okay? And we say this N choose R, N choose R. So we're gonna take N elements and we're gonna choose R from that. Okay, so N choose R. Now, like I said, we didn't need the formula because we have our trusty calculator, okay? So we just need to be able to do this on the calculator. So as an example, we just did this problem over here and I told you that I knew that the answer was 6. So what we're setting up here would be that we were starting with 4 people and we're gonna choose 2 people. Okay, so 4 choose 2. All right, now here's the dealio on the old calculator. Let me come in a little bit here. All right, so you turn the calculator on and we're gonna start by putting in the 4. Okay, so start there. And then we're gonna go to this math button right here, math. Now across the top, do you see the one that says PRB? Slide over to PRB, and you notice the third one down says NCR. Click on it. Then don't forget to put your 2 in there and hit enter. And we got 6. All right, now that is not 6 because 4 plus 2 equals 6 or anything like that. That just happens to be a coincidence there. So let's say that I wanted you to do 5 choose 2. So what if the club has 1 more person? Now there are going to be a lot more options for their committees, aren't there? So here you can either go back, you can either go back and do the whole process over again. Okay, so with the math over to PRB, or you can do this, second entry. And notice how that puts the thing right back there. And then I'm just going to go over and change that to a 5 using my arrows. and boop, okay? And this actually gives us 10. So if there were 5 people in the club and they needed a committee of 2, there are 10 ways to do that, right? Okay, so let's look at some other ones here. So let's go with 6, choose 1. Okay, so let's say that you're, in a group that has 6 people and you need to choose 1 person to go do something. So in this case, since you're only choosing 1 person, there are 6 different options, aren't there? Okay, so when we have a 1 here, no matter what this number is, and you're choosing a 1, then it's just what that original number was. So if we have 127 people in our club and we need to choose 1, that's 127. Okay? Now you can always do that in your calculator. I promise that's what it is. Okay, but if you can get into the habit of noticing when there's a 1 that there's a shortcut to do here, it makes your life that much easier. So I'm going to use this other notation for the next one. So you might see something like 7, choose 0. Okay, different notation though. 7, choose 0. Now, if there are 7 people in your club and you need to choose no one, okay, you're not doing a bake sale, okay, how many ways can that happen? And at first you think, oh, that's just 0. But there's actually one way that can happen. Everybody stands here and doesn't choose anybody, okay? One way that that can happen. Okay? And again, if you don't trust me, let me show it to you in the calculator one more time. Okay, so start with 7. Then go to math, over to PRB, down to NCR, plug in 0. See what I get? 1. Okay, so there's one way to do nothing. Just do nothing. So that means anytime you see a 0 as the second number or the bottom number, the answer is 1. So 11, choose 0 is 1. Now, how about 5, choose 5? So there are 5 people in the club, but you need all 5 people for the bake sale. So all 5 people that are sitting here are going to go right over here and do the bake sale. So how many ways can we do that? That one is also going to be 1. Okay? There's one way. You just all say, okay, let's go do the bake sale. You do it together. All right, so the thing about combinations is that these things can get large fast. So as an example here, what if I asked you to do 52, choose 5? Now I want you to think about this before we actually do that. 52, where do we have 52? 52 should be a number that starts to pop into your head. And 52 is how many cards there are, right, in a deck? 5 would be the number of cards in a poker hand. So here we're going to figure out how many 5-card hands there are. So we're going to go 52, choose 5, and this equals 2,598,960. So in a deck of cards, if you deal out 5 cards, a hand of 5 cards, there's over 2.5 million ways that that can happen. Okay. So what if you want to get Jack, Queen, King, oh, I forgot the 10, sorry. 10, Jack, Queen, King, Ace of Spades. I don't know why I wrote 4 want. You want. You want the 10, Jack, Queen, King, and Ace of Spades. So this is called a royal flush. And now there's only one way that this can happen. You've got to get the 10, Jack, Queen, King, and Ace of Spades. So there's only one of these hands. So if we want the probability of the 10, Jack, queen, king, ace of spades, there's only one way that that can happen out of how many different poker hands in total? That 2.5 million, so 2, 9, 5, 9, 8, 9, 6, 0, which means the probability of getting your particular hand is 0.00000385. 6 zeros and then the 385. So very small chance of this happening. Right. Okay. So what do you think of that? Okay, so the fundamental counting principle you will use to do some calculations for some probabilities, and then this, the combinations, we're going to use that also in the next section, okay? So the combinations is going to kind of come with us a little bit, okay? Alrighty, so that should do it for this lecture. Sorry for all of the noise in the barn, I apologize, but I will see you next time.